my presentation. I wanted to look at the state of RWD and RWE. So, and you know, my main experience is in clinical trials. We will speak about types of trials. So what types of trials, comparative trials, do we have? From the point of view of statistics, we base on the theoretical hypothesis. First of all, the hypothesis is to be put forward. We have epidemiological trials, instrumental, observational trials. Their goal is to put forward some hypotheses that are to be proved by the trials. And speaking from the point of standard clinical trials, we have statistical hypotheses, inferiority, not inferiority, and others. These are the standards that we know. Where is the place of real-world data and real-world evidence? First of all, observational trials. Here we have registers, cohort trials, and so on and so forth that contain real-world data and real-world evidence. But what about the supporting hypothesis? Because we speak about the transfer to RWE, and evidence is supposed to prove something. And if we look at the FDA documents, they analyze only data received in only in observational studies, the pharmacovigilance system, the medical comparison of medical records. But we have real-world data received in observational trials as well. We have simplified, randomized trials based on real practice. They are not classical, but they are also trials. There are hybrid trials where real-world data are used as a means of current control, and interventional trials. There are very many questions arise, and the first, we need to understand, in order to define the transfer from the data to the evidence, we need to state the goal, divide the goal. It can be the assessment of risks, risk of side effects, adverse events. Prognostic models can be used. We can prognose risks, we can prognose effects, but these are still models, and how evidenced they are, we can't say. One more goal is to assess the effect of adjacent factors, supporting therapies on outcomes of the well-known therapy. It is quite easy to use modeling to build these trials. In order to calculate the sampling, it is very good to use the RWD, RWE data. There are a lot of papers that were published about checking the coordination between the results of the trials and real-world data, and the number of such publications is growing. The next goal is comparison for prospective trials. If we do not have, if we can't provide a second therapy, we can take this data, the existing data from other trials. So these are the things that are connected with the existing clinical trials. But efficacy data of trials raise very many statistical issues in prospective trials. In experimental trials, we are to prevent systemic errors in sampling, control, randomization, blinding. RWD trials that are built on real clinical practice, they are to be in conformity as well. Probably we won't have blinding in these situations because in real practice it is difficult to blind. But in observational trials, we can make an adequate sampling and execute an adequate control. And a lot of issues arise here as well. We have traditional, interventional, and observational registers. What is population different from? Traditional, heterogeneous, the groups of comparison. There are absolute comparative, in usual trials, and interventional. We have problems, but a very difficult problem arises in observational trials. The groups sometimes are not comparable. The strata are different in the number. We assess outcomes clearly formulated in classical trials. They are defined by the protocol. In interventional trials, as to observational trials, the databases do not always register the same approach to the registration of outcome. Sometimes you look at the observational trial and try to unite all these trials into one cohort, into one system, and you get the situation when here it is registered by one questionnaires, and here it is defined by another questionnaire, so they do not match. The same happens in the registers. They are not standardized. Time points are not standardized. In traditional trials, we have traditional time points. In observational trials, we have only real practice. When it comes, it is good. Missed data, a lot of missed data in observational trials, and they cannot be regulated. If in traditional trials, we keep an eye on them. In interventional, we can also keep an eye on real-world data. In observational studies, this missed data cannot be restored, and people cannot be asked about it. And now let us come over to statistics. The procedures, what procedures are written down in interventional trials? There must be some standardization in the protocol. It must be written down what we want to find. But in observational studies, there is a big issue. For example, the supporting regulatory decision says that the trial can be made without a control group, but we may use preliminary data. The same questions will arise here. Interventional trials, they are large, pragmatic, hybrid. Mostly they look at the frequency, and they make frequency analysis, survival analysis, but it doesn't require exact time ranges. But as to time ranges in other methods of statistics, the problem arises. We need to compare the figures at one and the same time points, but the registers are different. And we cannot get the data about one patient at the same time points. The same about assessment of risks. At what time do we assess risks? What is the time window do we set to assess the risk? And what effect does this risk window have? So the number of observational trials is growing rapidly, but the analysis is mainly descriptive. They do not assess efficacy. They do not forward any hypothesis. They just assess outcomes and present them in the form of descriptive statistics. If we look more attentively, we will see that they use mainly logistic regression, ROC analysis. Can we assess the size of the effect? We may build up a logarithm. We may model something. We may make a curve, find some coefficients. But how can we numerically assess the effect in accordance with, by regression? Virtually, no. Modeling, prognosing, they all can be used. What is important what we make regression? Valorization, validation, yeah, of for other subjects. We have heard previously 2 reports about it. The assessment of sensitivity. As to comparative effect, here, if regulator allows us, we can use computer simulation. These are simulatory trials, and here we can assess the effect as it is. So my time is up. Okay, let us skip some slides. What problems do we have with registers? First of all, not standardization of collected parameters, non-standardized coding. But you know, in FDA, for example, they have standards for electronic information and coding of data. We do not have such standards, but we have to develop them. The problem also is that very many errors that exist in databases. If in clinical trials there is monitoring of what is put into the database checked, and sometimes you get a database where visit number 3 is earlier than a screening visit, so nobody has checked dates when these visits were made. Data exchange. You know, register owners are reluctant to share their data. Even our national database of pharmacovigilance has the data of the adverse event, but it is not connected with the outcome of the therapy. The database doesn't have a database of medical institutions doesn't have a column to register it. And of course, evidence, it is better to get evidence from the very well planned, very well structured clinical trials. And it is always important to consider the clinical significance of the effect, not the statistical significance of effect, because we sometimes have very many patients and say, for example, the difference between men and women can become significantly important. Now, the use of artificial intelligence for making regressional models is also discussed. But is it justified? Will we get effect, and how we can get this effect? And the next point, development of the statistical analysis for different conditions. It is important, otherwise we won't be able to go further. You know, we have no recommendations for making a statistical analysis, and that may hinder our future work. So planning, planning, and planning.